In this video, we're going to talk about a very important rule. That is the chain rule. This rule is going to allow you to find the derivative when we have what's called the composition of two functions. Think of it as a function inside of another function. For example, if you look at this problem here, we have y equals parentheses with a function inside. So think of this as being inside of another function. The power is the outside function. So when you have this situation, you have sometimes two choices. In this problem here, we could consider doing the algebra step, cubing the parentheses, which means parenthesis, 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 all multiplied together. That's a lot of multiplying, and it's a lot of terms. But that is an option if you wanted to go that way. Sometimes we don't have that option, and we have to use the chain rule. This is a good example for me to introduce the chain rule on, so I'm going to start with this one. But just understand, there are sometimes situations where you have a choice, like this one, where you could use algebra to avoid the chain rule. All right, so the chain rule is for problems where you have one function inside of another function. The definition is down here in the box. So we call this a composition of two functions, F circle G. It simply means that you have a function G inside of a function F. You guys keep hearing me say the inside and the outside. That's really going to be your cue or your key for finding out the different pieces you need to follow the formula. So I actually prefer this definition here where you have the dy dx, but this is exactly the same thing up here. But I'm going to talk about this one. Dy dx, the derivative of y with respect to x, is what we want to try and find. What this formula says is we can find the derivative of y with respect to u. They're letting u replace whatever's inside of your function. So in this case, u would be what's inside, the 2x cubed minus 1. So I'm going to write that down. So u equals 2x cubed minus 1. After you've picked your u, you then need to rewrite your y. But instead of leaving the inside as it was originally, replace it with the u. So in this case, it would be u, all of this is u, to the third power. Now, this is what we're going to later refer to as the inside and the outside functions. So u is your inside, and this power is the outside. According to the formula in the box, we can find the derivative of dy dx, what we're looking for, by finding the derivative of y with respect to its new variable inside, the u, times the derivative of u with respect to its corresponding variable, which is an x inside. Notice, in terms of algebra, if you cancel the du's, you're left with dy dx, which is really what we want. Don't do that though, because that means you're going back. So we've put in the u, we've brought in the u to separate the two function operations so that we can worry about their derivatives separately. All right, so we dy du, we're going to take the derivative of y with respect to u. So let's do that. So what is the derivative of y, or y prime? I'm not using y prime because I want to make sure you understand that these have different variables inside, the y and the u function. So dy du, what's the derivative of u cubed? 3u squared. There you go. All right, now u, what's the derivative of u with respect to its variable, which is x? So du dx, power rule, 3 times 2, that's 6x to the new power 2. The derivative of the negative 1, well, that's gone. All right, so according to our formula, let's see if I can move this down. Maybe? Nope. All right, so according to our new formula, the chain rule formula, we simply need to multiply dy du, which we found, he's this guy right here, times du dx, which is this guy right here. All right, so dy du, that's 3u squared, times du dx, 6x squared. Well, that doesn't quite make sense. Why? What's wrong with this? Well, we can multiply the 3 and the 6, but look, we have a u and an x. If you look at the original problem, did the original problem have a u? No, u is something we've made up. So our final answer, we have to put back what u actually is. So multiply the 3 and the 6, that's 18. But instead of putting u, plug in what u was. So u was 2x cubed minus 1. Be careful, it still has a square on it. So the 3 times the 6 is the 18. U squared is actually 2x cubed minus 1 squared. and we have this x squared. I'm going to put him in front. There you go. This is the derivative of the original question using the chain rule. Right? Let's try one more in a formal way like we're doing here, and then I'm going to show you a so-called shortcut, just less notation. All right, so again, you have to find the inner function and call that u. So inside, I see we have t cubed plus 1 inside of sine. The whole thing, t cubed plus 1, is inside of sine. So I'm going to call that u. So if we let u equal t cubed plus 1, then what does that mean our y is going to be? Remember, y is the original function with u plugged in. So that would be just sine of u. These are two functions that we know how to take the derivative of using our basic derivative formulas. So let's do it. Du dx, that should be a t up there, notation. Du dt, take the derivative, so power rule, 3t squared. And then y, derivative with respect to u. The derivative of sine we know is cosine. The inside is still u. And then the chain rule says the derivative of this function, or the dy, in this case dt, is going to be dy with respect to its new variable times that same variable with respect to its variable inside, which is t. So according to chain rule, we just have to multiply these two together, the derivative of what's inside times the derivative of what's outside, and we'll get our answer. Now, in terms of order, we write cosine of u times 3t squared. Now again, our original function was just in terms of t, so u is something we've totally made up. So what is u really? We got to plug it back in. That's t cubed plus 1. It's what we chose it to be at the beginning. So this is really cosine of t cubed plus 1. And I usually like to put everything else in front of that big function. Is it necessary? No, you can put it at the back, but it's less confusing to know for a fact that the 3t squared is outside of the cosine. Some students get confused if I put it at the end and they start thinking, oh, it's inside. No, just t cubed plus 1 is inside. And that's the derivative of the original function. So this is the chain rule for when you have a function inside of a function. This is the formal way of working it out. It is very useful. However, it gets a little bit confusing personally when you have multiple chain rules going on because of so much notation. It's a lot to keep track of when you have to do u and then another letter. Anyway, so instead I want to show you another method in my next video. So it's called inside-outside rule or outside-inside rule, and I'm going to show you how to do that one. So this is one technique for finding chain rule derivatives, and I'm going to show you another one in the next video. So study hard. I'll see you in the next one.